what is operational excellence? Is basically a mindset, a philosophy, accompanied by a set of tools and metrics and methods to bring excellence throughout an organization. When we talk about operational excellence in manufacturing, what is really important that to be improving processes, we need to be able to measure them. And one of the key metrics that we work with is OEE. I'm sure a lot of you have already heard this term and maybe have worked with it. It stands and is a great metric because it's very comprehensive. It assesses performance from 3 dimensions. It revolves around the performance of the equipment. So it measures first the availability of your equipment. In other words, how long are your machines running out of the whole available time? And then that is multiplied by the performance of your machines, which means how fast are these machines running out of like the fastest they could run. And finally, it assesses the quality of the output that comes out. We at Magnitude work especially with this metric because it's very widely used in manufacturing, as I said, to measure the performance. And we have been able to convert this metric into additive terms in order to measure all the nuances of additive production. When we consider OEE, and especially what does it mean to achieve 100% OEE, in additive, we can imagine that as an ideal production where our systems are running 100% of the time at the highest speed and produce perfect output. That is the goal of additive in the end, to achieve the highest productivity as possible. But as anyone that has worked with additive well knows, in reality, that's not the case. Most of the time, that's not the case. There are so many variables that affect the process performance that cause many things to possibly go wrong and have a lot of scrap. And the big issue of measuring performance in additive is that these traditional metrics, such as the OEE, don't really work out of the box for additive. It's not an easy translation from the OEE for into additive. And therefore, many companies or most companies don't use these kind of metrics to measure performance. This results in still having to work and on a trial and error basis. So, as you can imagine, the performance is far from ideal in the reality of things. To put it in Carl Brenter's words, he's the founder and ex-CEO of Material Solutions. He said that in AM, 50% efficiency is aimed for, which in any other capital-intensive process industry would be a joke. And he is not far from the truth. As I said, at Magnitude, we have been able to create OEE KPIs for additive. And thanks to that, we have been able to measure the efficiency of our customers, of the production of our customers in Metal AM. As you can see, the results that we found are quite astonishing. On average, we see that the efficiency of the process of these companies was around 40 to up to 45%. So even less than what Carl Brenter is striving for, of course. So we see that there is a massive waste of efficiency compared to traditional manufacturing. So where does this go? Here, I'm introducing the risks in Metal AM. Also, why is additive so unprofitable? When we review, when we work with customers in Metal AM, we find 3 main risks over and over. The first one is that there are many invisible production losses because the business of additive, it requires a high upfront investment that then has to be recovered throughout the year. But since because of these invisible production losses, that investment is very hard to recover. The second main risk in additive is that there are many limitations to capacity management. When we think about how amazing additive machines are, that they can work 24/7, it's sometimes such a waste that we realize they have to sit for a lot of the time, and the down are extremely high. That is also because the additive process is highly dependent on operations. The fact that there have to be technicians that work on the machines, that prepare the jobs, that unpack the machines. That's a high level of involvement of people, and as well as coordination of resources. The third risk that we see is that the process is so complex that it goes to impede corrective actions. Because of this complexity, the scrap rate is much higher than in traditional manufacturing, as well as much more expensive due to the types of parts these companies work with, and the costs of the material as well. And because of this complexity, engineers and operators have a very steep learning curve that often exceeds the employee turnaround. So these are the main three problems we identify when we work with metal AM companies. And I want to dig into the first one especially because I have limited time with this presentation. So when we talk about production losses, we have to try to identify what is the biggest loss along the production chain, because not all losses are equal. To do that, we take a look at the cost per part breakdown, which identifies the machine cost as the far larger component of the cost per part. When we realize that is the highest cost, that means that the machine time is what is really valuable for us to make sure that we take advantage of. And that means we really need to pay attention to minimizing the machine downtime. On that note, I want to offer you some tactics that we have been implementing with our customers to minimize the production downtime. The first mitigation strategy we try to implement with our customers is to measure the downtime as accurately as possible. This is really key. What we often find with our customers, I'll give you a specific example here, is that they try to get a rough estimate of the machine time distribution throughout the year. And the way this particular customer did it is that they measure the status of each machine at a certain fixed time. So for example, at 10 a.m. is building, then that counts for the whole day. If tomorrow morning at 10 a.m. the filters are being changed, that activity is being counted for the whole day of that machine. So that at the end of the year, you have a 365-day distribution of the activities that have been done to the machine. That might be somewhat accurate, you might say, but we'll see that it's not really like that. And at the same time, an issue that we is that there is not a fixed or often enough review between the downtime estimation at the beginning of the year that is used to define the hourly rate at which the parts you're producing will be sold, and the downtime layer that has been measured. So that is a very grave error to make. We'll see why in a second. So what we suggest to our users and what we work them towards is to measure every single downtime that the machines experience throughout the year, and especially measure that divided by type. Not only what kind of downtime activity it is, but only whether it's planned or unplanned, for instance. And you can base that simply on your production schedule, for example. You just need to collect these information. You could use an Excel or some other tool that allows for data analytics or easy analysis and statistical analysis of your data. But it's really important that is done in the organization. And we also recommend to have at least quarterly downtime reviews against the original beginning of the year projections of the downtime. So when we did this with the customer that I mentioned in this example, we came to some revelations that are that we measured against what they measured with their methodology was off by 32%, which means we detected 30% extra downtime compared to what they did. Moreover, we were able to detect 2 downtime categories that flew under their radar with the methodology that they were using, as well as when we compared our downtime for the quarter to the estimation for the quarter at the beginning of the year. That estimate was over 40% off, which is a huge number. The second mitigation action that I want to discuss is review meetings. Extremely important to have review meetings. We find a lot of companies that don't have such practice, and we try to promote it as much as possible. So for those of you who did not experience production review meeting yet, briefly, we involve all the people that are involved in production, including production manager, engineers, technicians, and even salespeople when relevant to the discussion. It should be a recurrence of every week or every 2 weeks. And in these meetings, you basically sit in a circle with your team, and project managers usually have a few minutes to introduce what are the main issues they encountered, the main bottlenecks, and how they have tried to apply a solution, or what corrective actions they should be taking. The team then discusses, and the idea is that you can really share best practices or review best practices in the team. What we want to bring to the table from our expertise is one extra step. That is, the production manager or a senior project manager has to bring data to the table, to these review meetings. And the data that we propose to bring is divided in 3 aspects: data on capacity, data on quality, and the costs. More specifically, imagine the production manager, after everyone has addressed their issues, the project manager has collected capacity information on the past 2 weeks. For instance, how much downtime has there been in the past 2 weeks compared to the overall time? How much of that downtime was caused by this or that activity? And then going to quality, how much output was rejected, and how many breakdowns did the machines experience, how many interruptions, as well as the costs are very important in this case, because we want to know not only how much our rejections cost, but how much our downtime costs, because that is also a very good way of allowing us to better prioritize the bottlenecks. So this is the kind of analysis that takes quite some time to gather. We realize that, of course, with a software, it will be much more efficient. But it's extremely important that you are able to implement something like this, because based on data is really how you can view the trend from one review to the next and understand the improvements, the actual improvements of your production. The third action that we try to implement at facilities is having a production queue. By production queue, we mean a waiting that are ready to be launched on a machine. And that is also a standard practice from Kanban. The queue is needed because in additive it takes from 8 to 10 hours to prepare a build on average, which means that if your machine is stopping right now and you don't have anything ready to run on it, it's going to take you until the end of the day to launch something, and that is unacceptable, right? So what we see from our customers is that when we get to their facility, we find that there is no common practice for a queue. There is no requirement to have a queue for the machines. At the same time, we see that they do have a whiteboard with the machine schedule, but it's mostly about the ongoing schedule. There is not much look into the future and what is going to happen after the current build finishes working, let alone if it breaks right now. Also, another common practice is that job reprioritization in the queue that are manual. And that is absolutely not a good practice because it can disrupt the schedule and cause a lot of unforeseen downtime. So what we give as best practice in this case is to have a minimum of 24-hour queue set at any time for every system. This allows you to, in case of any sudden crash of a machine, to buy yourself at least 24 hours to figure out what job to launch next. It's also important that of these 24 hours, it's not like you have 3 jobs of less than 10 hours. You should have at least one of these jobs in the queue. It should last from this moment, the moment of the potential crash, until the next shift, so that you don't have to have someone on call that comes in during the night and turn on the machine because the bit is not long enough. Additionally, a second level of precaution. First, we usually recommend to have at least 2 builds in the queue so that the operator can have a flexible choice based on the circumstances. For instance, if the job machine, if there are issues with the file and so on. This is also a very time-consuming activity to be able to schedule a consistent queue for every machine, but it is necessary. And again, at some point it might be necessary to have a software to help you out with this task. All right, so let me present you our case study. We have been working with this AM Bureau, and we have implemented our software Optimo in their 7 machines. we have implemented a downtime analysis. We have been able to gather production and that the team has been using on their recurring review meetings. And as well as we gave them a tool to not only visualize the existing machine queue, but also to easily prepare the machine queue for each one of the systems that the company had. At the end of the first quarter from implementation, we were able to measure that the company had consistently a 65% downtime, which is a lot and much more than what they expected originally. But at the end of the quarter, we were able to reduce the costs by over $18,000, which for a quarter is not bad. And that was thanks to the way the company was able to implement tactics to improve the pipeline, for instance, having the queue, as well as addressing bottlenecks thanks to the review meetings. All right, so we arrive at the key takeaways of this presentation. What I really want you to take away is that you should really try to put more effort, as much effort as possible into measuring downtime. With Excel, with any other tool that you might see fit, because that's really going to change the way you evaluate your bottlenecks. As well as please review this downtime against the original projections and adjust the hourly rates when needed. These two activities especially might take a lot of time, but they are worth it when you look at the benefits in terms of production efficiency. Also, remember that review meetings are very important to implement continuous improvement. And we really recommend to do this through the use of data, especially on these 3 dimensions that I gave you example on: capacity, quality, and costs. The final takeaway is to have a queue ready for every machine. Probably all these actions together do require a lot of time. It's probably like a full-time job. So at some point you might consider trying to automate this with a software. Thank you, and that's it. And
wow,
we're ready for the Q&A.
amazing
I hope.
And
okay, I'm a little bit off time.
No, it's actually perfect. And the best practices that you shared were really amazing. To anybody interested in taking their metal AM production to the next level, everything you shared here is like a Bible. So thank you so much for sharing. We have a few questions here. Which downtimes do you see that tend to be the highest in metal AM?
Right. So I would say the downtime we find is inefficient parameters. Thanks to, I briefly explained OEE before, and we adapted the performance metric to Additive, which is the KPI that measures how fast your machines are running compared to the ideal speed of the machines. And through that metric, we are able to measure parameter inefficiency, for example, on the basis of how much build space is used, whether the parameter set is efficient. We even take into account the volume of the supports. Overall, how fast could you build this build? And what we really find is that efficiency is astonishingly very low. So it goes on around 60% efficiency alone. So it's not that high. And secondly, I would say the downtime between builds. That is really a high downtime. Yeah.
And on that note, I'll go to the next question and
Yeah.
say, why it takes 8 to 10 hours to prepare a build? For those not acquainted with the metal AM.
Yeah. That is because from the moment you have the request for a quotation, very often you need to adapt your build for additive, design for additive, right? You need to make sure that redesign work, and then you have to consider the orientation, the way you set up the supports. I'm probably not the best person to talk about this since I'm not an engineer, but that's what we know. It takes a long time.
That already answers the question from. So you are seeing this from a perspective of a printing service bureau. So that's explains
yes,
a lot.
Exactly.
Kate, by the way, you can already stop sharing your screen. So that,
yes.
And I will go to the next question. Who is responsible for providing the data for the review meetings, and how much time should they dedicate towards this every week?
So one method for that will be that each one of the engineers, for instance, if one of the engineers in production is responsible for, let's say, a machine or a material, they should be in charge of documenting how much downtime they experience. And that could take half an hour to an hour every week prior to the review meeting. If you're doing the review every week, then that's how much it will take you per every engineer. And then if the production manager or a senior manager wants to put all the data together, especially with regards to what I explained, capacity, quality, and costs experienced during the past period, that might take some time longer to put everything together. Yeah, that's why it comes in handy to have a software.
Yeah, absolutely, exactly. Are you working on some software for all these kind of optimization?
Yeah, luckily we have worked on it already. It's
nice.
It's already, yeah, it's ready, and we are able to do all of these practices automatically already. So
that's awesome.
able to really work on streamlining these processes, so that the engineer's time investment in these things is minimized.